So let's begin with the introduction for experiment 2. In this experiment, we will be using micrometer screw gauge and vernier caliper to take exact measurements. We are concentrating on determining the density and volume of a glass block and ball bearings. These particular tools contribute in an accurate measurement of length. These length measurements, along with the readings and electronic balance, allow us to compute the material's volume and density. It is a useful method to see how various materials, such as glass block and ball bearing, that have a different volume and densities. It is not just about numbers. Therefore, rather than just studying measurement, we are also employing instruments to understand the nature and origin of material difference. So there is two objectives for this experiment. So the first one is to determine the volume and density of ball bearing by using micrometer screw gauge, and the other objective is to determine the volume and density of glass block by using vernier caliper.
Procedure for micrometer screw gauge. Zero error is being determined. After that, the diameter of the ball bearing is being measured. After that, step 2 is repeat at least 3 times at different position of the ball bearing. Fourth, all data has been recorded in a table. After that, the actual diameter been calculated, read took into consideration the zero error obtained earlier. After that, the width of the ball bearing has been determined. And after that, the density of ball bearing has been calculated. Procedure for vernier caliper. First, the whole number of small divisions been counted on the fixed part of the caliper that are to the left of the zero mark on the vernier. This gives us the size of the object, the nearest number of the whole millimeters. Second, the first mark on the vernier was found to line up with one of the marks on the fixed part of the caliper. The value of the mark on the vernier then told us how many fractions of millimeters were needed to complete the estimate of the size of the object. Third, determine the zero error of the vernier caliper. Fourth, the length, width and thickness of the glass block are being measured using the vernier caliper. Fifth, step 2 is repeat at least 3 times at different positions on the glass block. Sixth, all the data has been recorded in a suitable table. 7. The actual measure was calculated by taking into consideration the zero error obtained earlier. After that, width of the glass block has been determined, and after that, the density of glass block has been determined.
Based on the experiment, here are the results for ball bearing and glass block. For ball bearing, the diameter of the ball bearing that are being measured using a micrometer screw gauge. And for the glass block, the length, width and height of glass block using a vernier caliper. For the observed reading of ball bearing, on the first attempt, we get the diameter of ball bearing of 19.10 and the radius of ball bearing of 9.55. On the second attempt, for the diameter of ball bearing, we got 19.00 and for radius of ball bearing, we got 9.50. On the third attempt, the diameter of ball bearing, we got 18.48 while radius of ball bearing of 9.24. For the average of diameter of ball bearing, we got 18.86, while the average radius of ball bearing with 9.43. For the true reading of ball bearing, on the first attempt, we got 19.10 for diameter of ball bearing with the radius of 9.55 millimeter of the ball bearing. On second attempt, we got 19.00 of diameter of ball bearing while the radius of ball bearing with 9.50. On the third attempt, we got 18.48 on the 9 meter and 9.24 on the radius, with the average of 18.86 on the diameter of ball bearing, with the radius of ball bearing with 9.43. Thank you. For the
Wow.
observed reading of glass block on the first attempt, we got the length of 10.15 with the width of 1.88 with the height of 6.18. On the second attempt, we got the length of 10.17 with the width of 1.88 and the height of 6.18. On the third attempt, we got 10.18 on the length, 1.86, 1.89 on the width, and 6.16 on the height. On the average, we got 10.17 on the length, 1.88 on the width, and 6.17 on the height. For the true reading of glass block, on first attempt we got the length of 10.15 cm with the width of 1.88 cm and the height of 6.18 cm. On second attempt, we got 10.17 cm with the width of 1.88 cm and the height of 6.18 cm. While on the third attempt, we got the length of 10.18 cm with the width of 1.89 cm and the height of 6.16 cm. On the average, we got the average length of 10.17 cm with the average width of 1.88 cm and lastly the average height of 6.17 cm. Based on the experiment, here are the analysis. For number 1, calculate the volume and uncertainties of the ball bearing and the glass block. For number 2, calculate the density and the uncertainties of the ball bearing and the glass.
For this experiment discussion, we determine the volume and density of a ball bearing a glass block. To ensure accurate measurement for their dimensions, we utilize tools such as vernier caliper and micrometer screw gauge. The density formula, P equal to volume over mass, was instrumental in assessing the material compactness. We weighed the object to find dimensions and applied scientific formulas V equal to 4 over 3 pi r to the power of 3 for the ball bearing and the V equal to length times weight times height for the glass block to calculate their volumes. Our meticulous recording of measurement considered any potential error. Upon obtaining the volume data, we proceeded to determine the density in line with our experiment objective. Additionally, uncertainties were computed using the standard deviation formula outlined in our lab manual. This direct, this direct approach allows us to successfully explore the volume and density characteristic of a studied object.
In conclusion, our experiment measuring the density and volume of glass blocks and ball bearings with vernier calipers and micrometer screw gauge was very instructive. We were able to comprehend that various materials, such as glass blocks and ball bearings, have distinct volumes and densities thanks to the accurate measurements. To improve the accuracy of our mass readings and the dependability of our findings, we employed electronic balance. This method allows us to investigate the qualities and difference between materials going beyond simple calculation. All things considered, the experiment proved how crucial accurate measurement to developing an efficient understanding of material.
So next we have a introduction for frictional force experiment or known as a experiment 5. A common force that affects how objects move or remain in place is friction. In this experiment, common tools such as a block, mass, spring scale and string are being used to study static friction. These basic materials simulate everyday surface forces. So our goal is to measure the force required to overcome static friction in order to get a better understanding on how various materials affect this important force. By using everyday life objects, this experiment provides the spotlight on the wider principle of friction, which may be useful in the design of more reliable and effective systems across a range of industries. In this frictional force experiment, yeah, the only one objective is to determine the coefficient of static friction of different surface.
Procedure for frictional force. First, measure the mass of the wooden block recorded as m. Second, the spring scale and the wooden block with the string. Place them horizontally on the top. Third, place m 50-gram mass on the wooden block. Fourth, pull the spring slowly. Fifth, recorded the spring scales reading. Sixth, repeat step 4 to 5 for 3 trials. 7, we add another 50 of mass to the wooden block and repeat. 8, step 5 to 6, repeat the step until a total of mass 500 gram. After that, step 1 to 8 been repeated.
Discussion for experiment 5 is the experiment was done to determine the coefficient of static friction of different surfaces. The coefficient of static friction could be determined from plotted data of the graph, which are graph of static friction, Fs against normal force, and for the rubber surface and non-rubber surface. The gradient obtained from the graph was used to calculate the coefficient of static friction for each surface using the formula of gradient m equal to y2 minus y1 over x2 minus x1. From the graph of rubber surface, the coefficient of static friction is 0.7, while the graph of non-rubber surface, the coefficient of static friction was 0.3. The, the difference between the coefficient of static friction of two surfaces is equal to 0.5. While the experiment was conducted, there was some improvement that could be made. The observer should place their eyes perpendicular to the spring scale while pulling it. This is to avoid the error in reading that could affect the data. Next, take a set of reading by different observer during observation in order to minimize the parallax error due to mistakes in reading scale.
In conclusion, the factor of mass, surface, and inclination give the effect to friction. The larger the mass applied will cause the static and kinetic friction force to increase. Moreover, the rougher the surface, the higher the frictional force. Other than that, putting the block on an inclined plane will also increase the frictional force. Therefore, coefficient of static friction are higher with the rubber on.